we have to write this decimal number as a rational fraction. So first, what this bar above 27 means? It means that this 27 repeats. So we can rewrite that this is equal to 0.27, 27, 27, 27, and so on. What next? We can rewrite that this is equal 0.27 plus 0. We have 27, so we will substitute 27 by zeros, and next 27 we take 27 plus, and again we have these 4 first digits, so we have 0 now, 1, 2, 3, 4 zeros, and we have next 27, and so on. We can rewrite this number to this form. It's still the same when we add this. And now we see that the terms of this series form infinity geometric progression, where first term a1 is 0.27 and the Cannon ratio r is, can take first term and the second, or second and third. Any two consecutive terms we have to choose to calculate the r, and divide second by the first. So a2 over a1, what will be 0.0027 over 0.27. So this is equal 0.01. If you take a3 and a2, you will see that we have the same. The ratio is constant. So we have r, we have first term, and we see that r is less than 1. Absolute value of r is equal absolute value of 0.01 in our example. So this is equal 0.01, and this is less than 1. When r, absolute value of r is less than 1, it means that series is convergent, and we can find the sum by the formula. S is equal a1 over 1 minus r. So a1 is 0.27. 1 we copy minus r, we have 0.01. So this is equal 0.27 over 0.99. Now we will change these decimal numbers to fractions. So we have 27 hundredths over 99 hundredths. So this is equal 27 over 100 division. So we change to multiplication, and we have to flip whatever we have in the denominator. So we have 100 over 99. 100 we see that we can reduce. So we have that this is 27 over 99. What else we can do? We can divide by 9. So it will be 3 and 11. So this is equal 3 over 11. We change the decimal number to the rational fraction. This is my solution.